Yes, dear students, today we are going to start Unit 3 for our ICPM subject. Unit 3 title is Design Engineering. Now to just give a brief introduction about what we are going to study in this Unit 3 and why we have reached to Design Engineering as Unit 3. So obviously as Unit 1 we have focused about introduction of software engineering, then software engineering process models. So these things are covered in Unit 1. All traditional and as well as advanced agile software engineering process models were covered in unit 1 along with SDLC and all other details. Then for unit 2 we have focused on how to prepare an SRS, that is software requirement specification, in detail. So last topic of unit 2, my earlier video, was on SRS template. So what is requirement engineering, what is requirement collection gathering process, what is requirement analysis, these things were studied as introduction of unit 2. And after that we have focused on few UML diagrams because we have jumped to designing after requirements collection analysis. And after studying UML diagrams in as introduction point of view, right from use case till sequence diagram, after that at the end last topic we have studied as how to prepare a software requirement specification template, that is SRS template. So once that SRS template is ready, that means somewhere you are ready with your draft or documentation, or you can say report for your project. So same way you are going to prepare for your ICPM mini project also at the end, which you are going to submit as a part of submission. So now as we are knowing that what is software engineering process, what is SDLC, what kind of software engineering process models need to be studied and applied as per your project problem statement or problem domain. Then how to prepare requirement collection analysis part, then UML designing, how to prepare all the structure, and then coming for preparation of SRS template. Then comes in detail design engineering, because as I've told you that designing UML design, which we have studied in unit 2, it was just introduction point of view. But now actually we are going to go into the depth of design engineering, where not only UML diagrams, but along with UML diagrams you are going to see what is designing, then what are the different design patterns, design styles, that means architectural style which we are going to cover. After that we have component level design, then we have user interface design. So you very well know this term as UI UX, that is user interface and user experience. It's a very demanded area in the market today. And accordingly one more case study, and case study for unit 3 is based on web app interface design. So these are the topics which we are going to cover majorly in unit 3. So once again I am telling you, title of unit 3 is design engineering, and as the name suggests, in this complete entire unit 3 we are going to focus on different types of design. So first topic which I am going to cover today, where you can see the topic title displayed on the slide screen, that is system architecture and design. So this becomes your introduction of design engineering. So in my unit 3 folder, which I'll be sharing you once the unit is completed, unit 3 folder consists of different presentations. So obviously system architecture and design, there are 3 presentations, that is part 1, part 2, part 3. So this 3 presentations will be based on introduction and detailing of design process, then quality, design concepts, pattern, design model. After that we have the further major topics of unit 3, that is architectural design, then component level design and user interface design. So first you have to study all the introduction part and details of design model, then you have to focus on these 3 types of design. Once again I am repeating, the 3 types of designs are architectural level design, component level design and user interface design. Okay, so mostly questions will be asked on any of the type of design. So we have to be ready with, and we have to study all the design styles and types very nicely. So let's start with design architecture and design, that is the introduction of design model. So the overall design of a system, when we are saying, obviously it will consist of all these listed points. So number 1 will be computers and networks, which we are also calling as entities, modules, devices which are connected to each other. So now the terms are computers and networks. So obviously when we are having computers as devices with us or machines with us, we will be needing network to interact with or to connect or to associate all these computers with each other. So that means through these networks, via these networks, some kind of data or message flow or transfer will take place. So this we have seen in the form of UML diagrams. Second point is interfaces and protocols. So you can see in the bracket examples are also given. So there are actually going to computers and networks, there are many types of different computers and networks present. So whatever are applicable and feasible, that only we are going to cover in unit 3. Otherwise, when you are going to cover distributed systems as one of the subject in B, that time you are going to study wide area of networks, right? So here you can go with monolithic or distributed or client server or 2 tier, 3 tier, n tier, like this kind of structures. Interfaces and protocols. Now examples, obviously there are FTP, SMTP, HTTP. So there are n number of interfaces and protocols which are playing important role of bridging the gap, or they are establishing some connection between all these devices and machines, right? So databases is the third point. So it can be any type of database, maybe relational or your structural or distributed or whatever, tabular, flat, whatever. So different types of databases, again it is dependent on the type of problem statement you are dealing with. Next is security. So security, again, why the security is needed? Because there are n number of attacks existing. Like attacks are active attacks and passive attacks. Now this you are going to study maybe in your CN subject, an information security subject in B level. So attacks, when I'm saying active and passive attacks, just to give you a brief introduction, because our subject is not based on attacks, we'll be only focusing on architecture and design. But just to tell you, whenever you are coming across any of the interview or Viva question about attacks, then you have to talk about security attacks are of two types: active attacks, passive attacks. As the word suggests, active attack is something which is visible, which can be easily traceable and identifiable. But when I'm talking about passive attack, it is some kind of intrusion in the system because it is an attack, but it is passive in nature, so it is opposite of active. It is not that easily identifiable and visible or traceable. Fine. So passive attack, somehow we have to assume, or somehow we have to search it or find it that maybe this situation is due to some kind of passive attack. So once again, there are different types of active attacks, there are different types of passive attacks. That is a whole other topic in detail, so we are not going to touch it. But just understand security mechanisms or security techniques or approaches or algorithms are needed to deal with or to handle or to control these types of active and passive attacks. But whenever you're talking about security, you have to just remember there is one important term, CIA. Okay, whenever you're talking about providing security mechanism for any kind of attack. So C stands for confidentiality, I stands for integrity, and A stands for authentication. So these three terms and concepts must be available or must be provided by any system to deal with any kind of attack. I repeat, it is CIA, that is confidentiality, integrity, and availability, or you can say authentication also. Once again, I'll write it for you people. It can be C. Now using this, it's very difficult to write, but I'm trying it. CIA. So once again I'm telling, it is confidentiality, integrity, and authentication. Okay, so security means you have to remember these three terms. Operations, when you're talking about, it is backup, archiving, audit trails, or inspection, log records or databases, follow-up records, logs, then monitoring. All these things are different operations. And software environments will be, as we have discussed this with at the time of SDLC, it can be your version, domain, programming language, okay, environment, what hardware is required here. So technology stack, which tools are required here, which softwares, all these things, fine. Now this is about overall design of a system requirements, fine. Next, going to the subsystem model, because now UML, talking about UML, it will be system and subsystem. So in all of the UML diagrams you have seen, there is a whole large system, and where you are drawing n number of other modules. So those n number of other modules within that system becomes subsystems, because subsystem is a subset or subsystem is a part of system. So subsystem model is a grouping of elements that specifies what a part of a system should do. So just now I have told you, subsystem is a subset or part of a big system, whole system, and each and every subsystem is going to have its own responsibility or job to perform. Component, in UML definition, component or in UML language, a component can be thought of as an implementation of a subsystem. So whenever you're talking about component, it deals with some software files or software log records or software modules or devices, fine. So we have one more UML advanced diagram as component diagram. Okay, so component is also one of the important term here. Now going to component is a physical and replaceable part of a system that conforms to and provides realization of a set of interfaces. So basically this particular order form.java is a component design. Order form of .java is component notation. So you can see it's a simple rectangle with this small, you can see ports here. So these two small rectangles on left hand side are called as ports, P-O-R-T-S. So when we are saying these are ports, that means this particular component is going to interact with other entities or external world with the help of these ports. Okay, and .java is an extension because I have told you component deals with software files, okay, or software packages or modules. So it will have one or the other extension with its name. So order form.java is a basically Java file or artifact. This next is a node, which is looking like a cube. So you can say node is a server, name here example. It is a physical element that exists at runtime and represents a computational resource. Now this particular node is used in deployment diagram. So once again, deployment diagram is an advanced UML diagram like component diagram. So deployment diagram deals with hardware devices or hardware nodes or machines. So server, computer, different machine or system, all these can be your different nodes used in your project. So the notation or symbol for a node or a hardware device is cube. Okay, so just understand when we are talking about component, it is software file or artifact. When we are talking about the deployment diagram, it is a node as a basic module or device here. Fine, so it's a physical element. Going further, system architecture examples, few examples they have given as web browsers. So you can see web browsers provide a flexible UI through an extensible architecture. So you know many web browsers you people are using where some or the other kind of result or outcome gets displayed. So data types will be helper applications, plugins, protocols, can be a number of protocols, executable code, whichever programming language or environment you are choosing. Fine. Then going ahead. Now when you are talking about web interface, obviously it is going to work on www, that is World Wide Web. So what is the basic architecture? That web browser which is visible for you and wherever you are going to get your final outcome or resultant, so that will be displayed on your screen. That is web browser is at the client side, and obviously it is going to extract or retrieve data which needs to be displayed on the client's screen because client has requested for that particular data, so that particular data will be fetched from the database of web server. So you can see on right hand side it's a repository kind of stuff, metadata kind of stuff, or database or data warehouse kind of stuff, from where this client is going to extract or retrieve the data which is requested by that client. Okay, so static pages from server, all interaction requires communication with server. So basically this kind of structure is called as, even though it is on web, but this is client server model. So we have a number of client server types also, like it is 2 tier, 3 tier, n tier, whatever. Now next UML notation will be for deployment diagram. So just now I have told you in deployment diagram we are going to deal with node. So you can say personal computer and department server, all these two are nodes. So you can see the cube structure or notation or symbol used here. So within that node you can draw component. So web browser is a component on personal computer node and web server is a component on department server node. So that's what I want to tell you. You can combine or relate both component and deployment, that means both component diagram and deployment diagram. These two are advanced UML diagrams. You can combine both. So when you are combining both, you can call this as you are uploading or you are loading the software files that are components on or above node. So node are the hardware physical devices, okay, or machines or computers in the system. So in this way you can show this. Now you can see web browser is going to extract data from web server, the earlier diagram. Fine. So you can see the arrow is coming outside web browser going to web server. Next is API, that is application programming interface. So when you want to show this API as in UML diagrams, obviously it's an interface that is realized by one or more components. So you are going to draw a software component because it is component. So again it's a notation or symbol of a component, web server, and from there you can show two interfaces are coming out. That is get interface and post interface. So when you are talking about interfaces, there are two types of interfaces. One is required, another one is provided. So these two types of interfaces, I will try to write down here. Two interfaces are provided and required. Now provided is this particular interface shown here with straight line and full circle. Yes, so first is provided. I'll try to give you the symbol here in text format so that you will remember it. Which is full circle, and the another one is obviously when one is provided, another one becomes is required. So as the name suggests, it is required. Obviously it is not full circle here, it becomes semicircle, or you can say half circle. Just bear my handwriting because as there is no practice of writing with this pen on slide, I'm just making a note here because this can be one of the quiz question. So when I'm talking about the interfaces, there are two types of interfaces. These interfaces can be used in class diagram, in package diagram, in component diagram, and in deployment diagram. So there are two types of interfaces. There are provided interface and required interface. When you're talking about provided interface, it is full circle because it is contented, satisfied. It is going to provide something to the other entity or external world. But as the name is required interface, obviously it is missing something. It is not complete. It requires some data from some other thing, right, to complete its execution or working. So your required interface will be half circle or semicircle. But both these things are connected to a straight line. So you can see a straight line here and this full circle connected here. So get and post both are provided interface because they are going to provide something from web server to the outside world. Okay, so when you're talking about this interfaces notation, you can see web browser. It is dependent on this interface HTTP, that is Hypertext Transfer Protocol, and this protocol is which kind of this HTTP protocol is shown as what? It is shown as a provided interface. Obviously this provided interface is coming from web server because web server is going to provide some data from its metadata or repository to client, that is web browser. So you can see provided interface is coming out of web server. It is a component and that particular data from the interface is taken or retrieved or gained by web browser. So web browser is dependent on that data. That's why dependency arrow is shown from web browser side. And this provided interface, this is realization. In UML notation, it is called as realization. And in between, HTTP is an interface name. Now, many of the books and standard ideal representation of interface name starts with prefix I, capital I. So whenever you are attaching a capital I, okay, as per the Jacobson and Bush book, UML, Rambach, Jacobson and Bush, these three are the very famous authors and the best book in the world on UML diagrams. So in that particular book, the naming, okay, mechanism for an interface is with a prefix capital I. So now it is IHTTP, which clearly shows HTTP is an interface name. So any interface, maybe it is provided or required, all of the interfaces will have a prefix as capital I. So it is an indication, and more ideal representation will be that this particular interface name, again you are writing in between stereotypes. So I hope you remember these stereotypes, 2 less than sign and 2 greater than sign, are used in while you drawing UML use case diagram for includes and extends. So again interface names will be written inside stereotypes. So remember these notations for interfaces. Now coming to web user interface, that is CGI script. Okay, so it is common gateway interface. It is one kind of middleware technology between client and server. So when web browser is going to extract or retrieve data from web server is going to search those particular requests or data into CGI scripts. Okay, obviously CGI scripts is going to extract the data from some kind of repository, that is data. Fine. So web scripts can configure pages, scripts can validate information, all interaction requires communication with server. So now they are showing with CGI script as it's a middleware. So obviously web server is going to extract data from some repository, but it will be done via some middleware technology, that is CGI scripts. So you can understand what is actually happening in background at the server side. So now it is one step ahead explanation detailing of your web user interface. So like that, different UML diagrams are shown for explaining different scenarios. So now this becomes the CGI interface diagram. So these components might be located on a single node. You can see there are different components here: Apache, CGI script, MySQL. So this Apache acts as a web server. Obviously it is dependent on CGI script as a mediator or as a middleware. And CGI script is a component which is dependent on data which is coming from MySQL database. So it's a repository or metadata. So you can see whoever is providing data to the other entity from that particular data, from that particular entity, you can see provided interface. So provided interface will show that MySQL database is going to provide some SQL data or queries or whatever related thing to CGI script. CGI script is going to provide data with the help of this CGI provided interface to the web server Apache. And now Apache web server is going to provide the data on the web browser of the client for its request through the HTTP interface. So it's a protocol, but here it is acting as an interface, because HTTP, I have told you, protocol are used for bridging the gap between client and server or to establish a connection between client and server. So it's a very nice diagram of, you can say, component diagram, where you have seen 3 components. All these 3 components are interacting with each other with the help of dependency and provided interface, because one component is dependent on another component for the data extraction and another component is providing data to that dependent component. So this is the advanced UML diagram. Now coming to the web user interface of JavaScript. Now this is web browser again. Now web browser is working on HTML and JavaScript. You can see again that data is taken from web server, and on the web server side in background again mediator or middleware is CGI scripts extracting data. So now JavaScripts can validate information as typed. Okay, so whatever work this particular web browser or client is doing as a client request, that will be encoded in the form of a script language. So as on server side, CGI scripts are acting as a middleware. Same way here in web browser side, client side, JavaScript is acting as a channel or mediator. So whenever you're talking about JavaScript, this JavaScript is obviously a combination of HTML tags and Java programming language. So the both ways the client is going to work or encode its request and send it to the server. So coming to the next thing is UML notation package. So this is a combination, or you can say this is the particular symbol or notation for JavaScript package or any particular package. Now there are 2 ways of drawing this particular folder or this particular node, or you can say this particular module is called as a tabbed folder. Tabbed folder. Okay. So I'll write it down for you. Even though it is a symbol or notation for package, this folder where you can see a small rectangle on the top left bottom, not bottom, top left side, that is small rectangle here. That's why it is called as a tabbed folder. Okay. So tabbed folder or tabbed module is a notation or symbol used for package. Now obviously when you are writing any particular object oriented code, your classes and everything will be covered inside the package. So all the classes and objects will be covered inside package. So coming to the tabbed folder, or you can say packages. So whenever you are going to write any object oriented code or programming, inside packages you will have classes and objects. So inside this tabbed folder you can show class diagram, complete class diagram, or complete object diagram, or classes connected to objects. Combination will also work here. So when we are not showing anything inside this package or tabbed folder, you are going to write down this package name JavaScript inside this tabbed folder. But whenever you are going to show something inside this package like class diagram or object diagram or classes and objects, then this JavaScript, that is package name, will come inside this small top rectangle. So that is a notation or the way of drawing package in UML design. Okay, so understand this kind of folder where you are having a small rectangle on the top left side, it is called as tabbed folder, and whenever you are going to draw something inside this package like classes, objects or diagrams, then this package name JavaScript will be written inside this small rectangle. So it's a general purpose mechanism for organizing elements into groups. So some authors draw packages with a different shaped box like this, but the most preferred package notation is this top one, that is JavaScript. Okay, now again coming to the example of web browser, you can see again this is a component, web browser is a component, and each package represents a group of objects. So you can see within a component, see the hierarchy or the nesting of things. Component will consist of package and package will consist of classes and objects. So web browser is a component which consists of three packages here. First package is HTML render, second package is JavaScript, and third is HTTP. Fine, again they are connected through dependency. HTML render is dependent on JavaScript and HTTP to interact with server. So web browser is dependent on web server obviously, and it is dependent or it is going to establish a connection with web server through these packages. Fine, so again packages are coming inside component and classes and objects are coming inside package. Now you can see web user interface for applet. Now applet and Java swings are coming from event handling mechanisms when you are dealing with advanced Java. Okay, so just understand what it is. Applet will look like a applet windowing toolkit. It will output will be running or displayed on the web browser side, but that code will be executed on the browser only, even though data is taken from server, but whatever code or request that client has made, that will be executed and run on browser side, that is client side, but data is fetched and extracted from server. So you can say these applets will appear in a window format. Okay, whenever you are coming across any particular site or portal and you will get some kind of pop-ups like alert messages or some error messages, okay, sometimes they will appear in a window kind of thing. So that is worked with applet windowing toolkit, AWT package, and Java swings, both combination. So this is event handling, because whenever some kind of thing or event occurs, what kind of action and state transition will take place, that will be occurring in that pop-up or error or alert message. Fine. So web browser applets will be working on browser side, this client side, and that is going to extract data from server. Okay, so any executable code can run on client and client can connect to any server. So applets and Java swings, SWINGs, are going to work on event handling mechanism. And event, you already know, whenever some event is triggered or occurring, that time we are going to get some kind of action or state transition. So that's all about the first video of your system design model. Okay, that is the first introduction, first part of your unit 3 design engineering. So I'll stop today's session here. Now the remaining UML diagrams and remaining design models we will study in next video. Thank you.